Welcome to Autodesk TruPlan webinar series. This is webinar 2 in our series, and we're going to be focusing on composite laser projection. So we waited a couple minutes for everybody to join. If you are coming in late, you can watch the webinar in its entirety. We will make a link available. And I just want to be sure that I'm recording. Okay, it is being recorded. Good. So I'm going to get started. This is going to be very similar to the previous webinar we did in the fact that I'm going to start out by talking a little bit about the product. We're going to go through a couple PowerPoint slides where we talk about the functionality, and then we'll get into a live demo where I kind of show off some of these features, and then that will conclude with a question and answer session. If you think of any questions during the webinar, please do not hesitate to post them in the questions section of the webinar window, and at the end we will go back and we will review and try to answer as many of those questions live as we can. If we cannot reach all the questions within our time limit, I will go back and answer those questions and send out the answers at the same time we release the link for the pre-recorded webinar so that you can watch it offline. Okay, so just to get started here, my name is Anthony Mazzillo. I am a project manager for the advanced consulting team at Autodesk. Previous to that, I was a SQA manager and SQA engineer at Majestic Systems before we were bought out by Autodesk in 2014. So I've been working with laser projection and our legacy products, TruLaserView, for about 12 years now, and have a lot of experience with the laser projection for composites. So today we're going to start out with a review of the topics we covered in the TruPlan 101 session, and that's just going to be an effort to get everybody up to speed and on the same page. Once we get up to that point, we are going to go a little further. Where we stopped last time, we're going to continue with the advanced laser projection features. And then finally, we'll follow up with a plan for our next webinar in the series and answer any additional questions. So the first step we reviewed in our beginning webinar, our 101 session, was how you can pull data out of CATIA and prepare it for TruPlan so that it's a very seamless and easy transition from one package to the other. This was reviewed in the first one. However, this is not the only way you can come up with your stacking and your ply definitions in TruPlan. We're going to review creating those from scratch in one of our future presentations. But for now, I wanted to mention that if you have data in CATIA, it's very easy to pull it into TruPlan. If you don't have any data prepared yet, it's a very easy process to kind of create that data within the confines of TruPlan from scratch. So today, we're going to talk about just the basic use of TruPlan when it comes to laser projection, and then more of the advanced features, including laser targets, drift check targets, how are they defined in your tree, and how are they stored as laser targets so that you can access them and include them with your projection. We're also going to talk about the use of a laser projector and how you can assign different targets to the same laser projector so that when you get your data to the shop floor, the correct groups of targets are called out for each individual projector head. Then we're going to get on to some of the features that we always provided in our legacy products and exactly how those exist in our current product, which is TruPlan today, and review kind of how how they're used, and any new additional functionality that's come along. Then we're going to talk about the 3D text. This has been one of our most popular kind of advanced features for a number of years. And it's gaining better and better support in terms of being able to assign the text to different types of geometry. So this feature is only getting better as we go along, and I want to talk about kind of where we're at right now. Then all of our laser parameters, these once again have come over from one of our legacy product, and these are all really geared towards specific laser projectors and brands and the advanced features that they each support. With that being said, many of these features are brand specific, but that means that this list of features is not static list. It's always getting better. We're always incorporating more new advanced parameters as we get notified from the different brands and the different laser projection companies of different features that they support. Okay, and then we're going to talk a little bit about the webinar that's coming up, webinar 103, and what we're going to try to accomplish there. I'm going to stop with the PowerPoint presentation for now, and we're going to switch over to the live demo, where I'm going to show you each of these kind of advanced features, and then we'll move on to the topics for the next webinar. I'm just going to switch over. Hopefully you can see my screen. I'm in a live TruPlan session at this point. What I've done here is I already did the 3 steps that we started out with in our previous webinar. In other words, I did the XML export from CATIA to generate my composites stacking information. I also did a 3D export with the STL option so that I could get all my data into TruPlan. So this is my model. It's a shroud part. I've got a few things here in my model tree, but the TruPlan tree is where all of my information that came from CATIA exists, including my material information. So all the different materials and packaging that we had to find in CATIA shows up right here in our browser for TruPlan. In addition, we've got all of our geometry, including the surface reference geometry and all the geometry for each ply group, sequence, and ply. So we've got the definition for each ply in addition to the overall contour. And that definition includes things like material, direction, and allows you to bring the kind of information directly over from CATIA without having to redefine that. So everything you saw in your stacking tree now exists here. So that much we'd seen in the last webinar. Next, I wanted to show, once again, just the very basic laser projection. And so I'm going to select my plies group, and I'm going to click laser projection. So you're going to notice that we've got many of the same controls and functions as our legacy products. We're allowed to call this part whatever we like. By default, we call out the part name based on the part number we see in the model browser. We're going to try to put it directly back into the same folder it came from. We've got a variety of different output formats. You'll notice the classics, Vertex, LPT, lap laser, SL, and assembly guidance. For Vertex and LPT, we may have to change the names here, but the formats will be the same regardless of which companies buy out which other companies. So those formats aren't changing, but we may end up putting, Vertex space Gerber or LPT, and then in parentheses Faro. The other one that I want to note here is the DXF. Now this is a new format we did not have in any of our legacy products. The effort here and the intent of the DXF output is to provide a kind of a neutral file format export that's got all the laser geometry but also gives you the ability to kind of reverse engineer and read that DXF file back into other CAD systems. So you could read this back into TruPlan. You could use those shapes in the DXF file to kind of rebuild surfaces, whatever you like with that. You could even read that DXF back into CATIA to compare against your original surface and your original design. So this DXF is a new format, and it's more geared towards generic file format production than any of these specific brands. The next thing you can see is that we've got our entire list of plies and cut pieces, and you can either select those by hand here in your tree, in your browser, or you can select them from the graphical view, or you can simply select them from the list here. So very similar to how this operated in the past, when you're selecting which plies come along. By default, of course, all the plies are going to be selected. We've got an axis system that we allow you to select, a tolerance, and a maximum length. These are all throwbacks from the legacy system. We did do a slight change to the resolution, angle, and step commands that we had in the legacy product. They have been replaced by tolerance and maximum length, which end up having the same effect. So the tolerance controls points along any curved surface, and the curved boundary that actually curves and is not a straight line. The maximum length would take more of effect on those straight segments and force additional points where we need them. Once again, just like our legacy version, we got the 3D and 2D export. We've got the rosette, seed point, and seed curve. And then, of course, we've got the classic preview command. At any point, I will point this out, at any point you can click the help, and the help will bring you into a context-sensitive help for this command only. Or you can simply click help here in the TruPlan ribbon, and that will bring you into our overall TruPlan help page. So that's the very basic use of TruLaser. You saw this in the previous webinar, but I wanted to get everybody up to speed and on the same page. So a normal use of TruPlan for laser projection, you bring in your data, whether it's from CATIA or any other source. You verify that it looks okay in your browser, and then you would click laser projection, select the plies you wish, preview them, and then once you're happy with the preview, you click OK. At the end, it's going to tell you exactly what happened, if there's any warnings, if it took, how long it took. All this kind of information is going to be recorded, and then it's going to be passed back to you so you get an idea of what just took place. So that's the very basic use of TruPlan for laser projection. Now let's get into some of the more advanced features that we were talking about in the slideshow. So the first thing that we had in our legacy product that we really need to be able to do here as well is to be able to call out target points so that those can come along with the laser projection data. Now, it doesn't matter if you're using a brand like LPT or Vertec where they actually store their target points in a separate file, or if you're using a brand like LAP or SL where they store their targets in the same file. TrueNest recognizes which brand you're writing out to and will include the target points in a corresponding way. So the first thing you need to do to define a target is to actually have a point defined. Defining a point in TruPlan is very simple. You simply select in your browser where you want that point to go. So I'm just going to start the point here in the geometry set, and I'm going to say new point. Okay, now it's going to ask me where the point goes. I can either enter the location manually based on my list of points I've got, or I can just kind of come out here and try to select some existing geometry to kind of associate that point to. So if I come out here and select just a point in space where we had one of our pre-existing targets, it's going to select that point for me, and I'll say OK. So now I've got a new point, And let me just get to the bottom of the list. Okay, so here's my new point I just created. And once I've got a point, then I'm allowed to reassociate that point and call it a target. So you see I've done a couple of them already here. I'm going to choose laser targets. I'm going to select that I want to create a target. And then I'm going to tell it which point I need to use. So I'll go back to the bottom, select my new point. There we go. If I want to include a comment, I can. If I want to include a drift check flag, I can. So normally a target is simply used for the laser projector to determine where it exists in 3D space with respect to the tool that it's trying to project on. And that's done initially in order to kind of get the laser projector into the same frame of reference as the tool. One of the things that many of these laser projector brands also offer is a drift check, so that every so often the laser is going to go back and recheck to be sure that the tool didn't move underneath it. And that's what's called a drift check. Anytime you call out a certain target for a drift check analysis, those are going to be the targets that are rechecked every time that the drift check is run. If you don't call any of them out, the laser projector tries to use all the targets for a drift check. And that can be a problem. Say, for example, if I'm standing in the way of the tool here on this side, I may only want to do this and this point as a drift check. So by calling out only certain points as a drift check, it can make the drift check not only more accurate but more repeatable, since it won't matter if you're standing in the way. So I'll say OK, and then you'll notice right away I've got a new target that shows up in my laser targets list. So I created a new target, and that's going to come along anytime I create my laser projection data. It's going to bring those laser targets along. It'll know exactly where they are and reformat them so that the laser projector can understand them. So for example, even though we call this laser space target 5, if we were trying to push this to a vertex format where it does not accept spaces in the target name, we would go ahead and include an underscore instead of that space. So TruLaser is going to TruPlan is going to take the necessary actions to get these targets in the correct format for your specific brand. So not only the targets are interesting, but for many of the brands now, you can also pass sublists of targets. So it's not just an overall list saying these are all the targets we have to choose from. You can also segregate them and put them into smaller groups for each specific laser location. And so that's what we'll do now, because we can also pass that information to the projector system. So I'm going to just say laser projectors. I'm going to create a new projector, and then it's going to ask me which targets I want to include with that projector. So I can call the projector anything I want. And then I can go ahead and start to select these targets. And I can select one or more, and I can even select targets that have already been assigned to other lasers. So I could have some overlap here, and that's okay. So I've got 3 targets selected. I'm going to go ahead and say OK. Now I've got my new laser here called Demo. And if I select it, you can see I've got my 3 targets selected there. So if you've got a laser projection system that allows you to call out multiple laser projectors and pass different lists of points, then you want to create a laser projector here in the list to take advantage of that. If you've got a different laser projector system that only takes a single list of points, no matter how many projectors you've got, then you can just suffice by creating an entire list of targets. The other thing to note that the list of targets is going to be presented the exact same way in your laser file as it is here in the browser. So no matter what this is called, even if this was called laser target 10 and this was called laser target 1, they're still going to come out in this order no matter what you do in terms of naming. So if you want to reorder them, you can, but it needs to be done while you're creating them so that they're in the right order here, because that will end up making a difference in which way they're presented. So that's the targets and the projectors. Very, very similar to what we had in our legacy product. We're keeping the same functionality. And anytime I store my model at this point, it's going to save all the work I did with the targets and the projectors, so they'll be available later. So that's the targets. The next topic, a little more interesting, I think, is what we call extra geometry. So extra geometry is TruPlan's method of including anything that's not a ply boundary or target point or rosette. If you look at our basic data, laser data command here, we include things like rosette, seed curve, seed point. Those are included by default. Those are not what we call additional geometry. The ply boundaries, the cut piece boundaries, those are just basic projection steps, and they don't really qualify for extra geometry. What we're talking about when we mention extra geometry is anything aside from that. So a good example might be, okay, we've got a new extra geometry set, and wherever I choose to put that set in my browser is where that set's going to end up being. So I can choose Ply 2 and simply say extra geometry. And so this is going to look familiar to many of you legacy users. Now it asks me to choose what we're going to use this extra geometry for. Do we want to use it for 2D composites projection or 3D? Do we want to use this for composite nesting? Do we want to use it specifically for assembly or paint design? Do we want to use it for true laser for fasteners? Or do we just want to use it for plain TrueNest? So we've got a lot of options here. If you're going to be using the extra geometry for laser projection, you need to choose one or the other here, 2D or 3D, depending on what you want to do. So we're going to choose 3D composites laser projection in this case, and we'll say OK. And you'll see right away now I've got a new extra geometry set here in my browser, and it's basically waiting for me to add something to it. So depending on what I have selected, whether it's this one or this one, when I go to choose and select and include anything else, that's where it's going to go. So this pre-selection ends up being important. Whatever you have selected already ends up being the location for your new work. So I'm going to choose my new extra geometry set. And the first thing I would just want to talk about is if you wanted to include extra geometrical information. For example, a simple line segment. So what I'll do is I will say I want to create a curve, and I'm going to just move over to my existing sketch and say finish. And you see there's our line that we've got associated, and just zoom back in. Going to rotate around. Okay. So the next thing I wanted to show is text. So let's kind of open up our extra geometry and include some text here. So I got my extra geometry selected, and I'm going to say 3D text. And so we've got two different ways we can select where we're going to put the text. We can put it on a support, which means we need to select an anchor point that tells us where the text begins. We need to select a support, which tells us which flat plane the text is going to lay on, and then we have to choose a direction. So that's three different things that kind of have to be set up to begin with for us to get the direction right. Or we can choose just simply on an axis system. And I could choose like an existing axis system like my rosette here. I could say, okay, we want it to be oriented the same way as the axis system. So the X direction of the axis system will end up being the direction of the text. The Y direction of the axis system will be the up, and then the Z would actually be which way it's facing out. So instead of having to choose 3 things to tell us how to orient your text, you can just choose one simple axis system that's already been defined, and we know everything that we need to about where it should go. So then you would say, this is the value I want to show up here. And so this is going to be either hard-coded in, something like ply 1, or it could be something like a parameter. And the parameter is really nice because it allows you to do a single piece of 3D text and have it kind of change and update its value depending on where it sits in the browser. So if I wanted to say ply, I would just plug that in here. And now instead of just putting the word ply out there, it's going to actually look for the name of the ply in each case. So in this case, I've just got my extra geometry under sequence 10. So when we project ply 1, it's just not going to project the word ply. It's going to actually project the name of the ply based on these percentage signs. So that actually includes a variable. Some of the other variables we can use would be source, which is the path of the file that came in, the part name, which is actually the number of the part in your browser, the sequence, which would be listed here under the plies group, ply name, cut piece name, either material or material ID. Those can actually be different. We'll talk about those more in our next webinar. And then also the orientation. We've also got some custom parameters that you can use based on different parameters that are stored in your model. So depending on which parameters you've got in your model, there may be additional options here. The other thing we can choose here is the text size. This tells us how big, how large, or how tall the text is going to be. In general, what TruPlan is going to do is it's going to pass the text to the laser projector and allow that laser projector to kind of project it in the most efficient way. So we're just saying, okay, this is the location of the text, this is what the text needs to say, and this is the height. And then that laser projection system kind of takes over and says, okay, this is going to be the most efficient way to project this with no flicker. So I've got my text. The next thing we can do in the extra geometry is what's called laser parameters. And this is what I was talking about at the beginning in terms of having some brand specific functionality. So for example, we may have an information box and it says double check grain line. And that'll come up anytime they run ply 1. And it'll actually show up on the control. Okay? And that'll work for like a Vertex laser projector. Or we could do a similar thing and say we want a note and say double check grain. And so depending on which brand you've got, it may like the information or it may like the note. And so they do a very similar thing, but it's just one brand's way of doing it versus the other. We can also do some other special things like a message. A message would be something that shows up on like a LED crawl board. So if you have like an LED display connected to your controller, this would be the message that gets displayed. And so once again, we can kind of put whatever we want in here, and it's a way we can display text without adding additional flicker by trying to project that text with the laser. The next one we've got is called query. The query is only available on certain brands, but what the query does is it allows you to ask a yes or no question. Did you double check grain? Okay. And the nice thing about this is the question is asked during the projection. The operator needs to come over and answer it, yes or no, and then all those answers are recorded in the report for later. So the query is a nice way to add some sort of a QA check into your system. Next one we've got is literal. Literal is our way to just kind of include any text that you might want in your laser projection file that you don't necessarily want the laser projection system to do anything with. You just need it in your file. So I might say author, Anthony. And then I may do another one that says part 1, 2, 3, 4, 5. And another one that says today's date. Okay, so this can literally be any text we want. It comes out at the beginning of the laser file. It's commented out, so the laser ignores it, but it allows you to kind of encode any additional information you might need in that laser file. And then finally, the last one here is graphic. And the graphic is really cool because it allows you to kind of reference a digital picture at the same time you're using the laser to project something. So an example I always like to use is if you're projecting, say you're projecting ply 1 and you're projecting the boundary of ply 1. But ply 1 is a really tricky one that you got to get right, and it could go in one of two ways. What you would do is you would snap a digital picture of ply 1 in the real world after it's been laid down correctly, and then you would store that picture alongside your laser projection file. Maybe you want to call it ply1.jpg. Okay, so we're going to look for a file called ply1.jpg when we project ply 1, and it's actually going to show us a picture on the controller of that ply done correctly. The real beauty here is that we don't just have to say ply 1. We could say it's going to be in a different folder. It's not going to be alongside my my laser projection file. So I could say C images ply 1, or I could say ply1.png or TIF. The image formats are pretty much uses the standard image formats. Or if I even want to get more tricky with this and more intelligent, I could have set this up here on my plies group level, and I could literally say images percent ply percent dot JPEG. So what this is going to do is it's going to step through, and when we get to ply 2, it's going to look for a file called ply2.jpg. When we get to ply 3, it's going to look for a file called ply3.jpg. And so anytime it finds a picture, it's going to show it. If it doesn't find the picture, it just skips it. So it's a really nice way to say, okay, if we have any pictures out there to assist with our laser projection, we're going to call them a certain way in terms of their file name, and that way TruLaser is always going to know where to tell the controller to look for those. So the graphic, actually all these extra geometry features are pretty much brand specific, but there are additional features to allow you to do better things with the laser and get better control. Now the last thing I want to talk about before I turn it over for questions and finish up the PowerPoint is the location of this extra geometry in your browser. I talked about it for a minute with regards to the graphics, but really anywhere this exists in your tree is going to tell TruLaser, TruPlan that is, where to apply this extra geometry. So right here it sits inside ply 1. It's only going to do the extra geometry for ply 1. Or I could drag it up here to sequence 10, in which case it would take effect for ply 1 and all 3 cut pieces. Or I could drag it up one further level to plies group 1, and it'll take effect for every sequence in that plies group. So depending on where you locate this gives your extra geometry a lot of power, because you could define that extra geometry one time and really have it apply to each ply without having to duplicate this and copy and paste it over and over. Now the other nice thing about this extra geometry is that if I copy this from one file to the next, it's gonna retain as many of those characteristics as it can. So let's say we just had some literal text here that we wanted in all of our different laser files, no matter what. No matter what, I always want to say author is Anthony. I could literally just copy and paste this laser parameter from one file to the next, so it's always there. And so that is kind of the more advanced features of TruPlan with respect to laser projection. I was trying to save some time for Q&A. Let's see if we got any questions. So the one question I do see here is, does TruPlan nest flat patterns? So the flat patterns is something that TruPlan absolutely can do. It's called draping within the context of TruPlan, and that's done within the strategy and the analysis portion of TruPlan, so the producibility area. So to answer your question very quickly, yes, we will do those flats, or we can bring in the flats that you already had generated within CATIA or FiberSim or something. So as you can see, as I zoom out, I already had some flats for this one. So you can either produce those yourself within TruPlan using strategy and analysis, or you can take the existing flats that we already found. They'll be associated here in your browser just like normal, and then you can either take them, through our traditional nesting system, or you can run kind of on-the-fly nesting. So the nesting itself is actually a topic for our next webinar, and that's a good segue to talk about the topics that we're going to review then. So our next webinar, I'm not sure if it's going to be called 103 or 201, but it's going to be hosted in July. We plan on covering TrueNest for those flattened shapes, and also the strategies and analysis. So those three topics that I was just talking about: strategy, analysis, and nesting. So those are going to be the topics for the next webinar. So stay tuned, and you're going to learn a lot more about that question if you attend the next one. Okay. Looks like we got some more. How will extra geometry appear in the text file for assembly guidance? Currently, the open geometry does not read into our system. It's a good question. So assembly guidance has kind of given us a new file format recently that does better on things like open geometry. We always had that kind of disconnect with assembly guidance where they weren't always so forthcoming with their file format. We got a newer file format this year, and I think it's going to add some better support for these type of things like open geometry. The other thing you can always do, Eduardo, is to actually request examples of how they want the open geometry to be formatted, and assembly guidance will send you those examples, and by giving them to us, we can come up with a much more accurate file format that will be read better by the assembly guidance system. It's a good question. That's literally how we get better at writing out these formats, is by collaborating with you, the customer, and with these brands of laser projector to be sure we have the latest and greatest spec. Next one I already answered. Does TruPlan require inventor license? Great question. That's a great question. So as soon as you buy TruPlan, when you install TruPlan, it's only a license of TruPlan that you've been given. But in order for that TruPlan license to be active, it automatically comes with the license of inventor. And so even though you got a license called TruPlan, in reality you can use all the great functionality of the CAD design, all the great functionality of any CAD, where you can bring in those different CAD formats. You can use all the great functionality of export and storing models in AIM or IPT formats. You can get all that basically for free just by having the license of TruPlan. Does TruPlan support ply boundary offset for laser projection? Absolutely, it does. That's one of the biggest. That's one of the biggest features that TruLaser and TruPlan have always provided throughout the years. That ply offset is the crucial piece here, and we need to be able to calculate that ply offset very accurately, no matter what the situation. So absolutely, that's included. And that's really our biggest selling point. That's our biggest feature, and it always has been with our laser projection module. Will the current CATIA embedded files, laser projection data, open geometry and such, export for this application? That's a very good question, Jason. I haven't tested that yet. From what I understand, it's a possibility. I don't know if we've included it right now or what the status is there. I'll have to get back to you with a better answer on that. Because I understand the question that you want the open geometry you already had inside CATIA to come over to TruPlan. So I'm gonna have to ask our developers exactly where we're at with that, what the status is, and I'll get back with you. So that's one we'll have an answer for once we release this webinar as a recording that everybody can kind of watch and download. Matt Thorne, if you're still listening, do we get any other questions that I didn't see here?
No, I think there's one more actually.
Okay, I see it. Will TruPlan support open geometry projected in an independent frame without closed ply geometry? It's a good question. That's a good question. So TruPlan limits its laser projection capabilities. It does that on purpose. It tries to keep all the laser projection capabilities within the scope of composites. So TruPlan you can kind of think of as our composites module for laser projection. Anything outside the scope of that, where you might want to project frames or different shapes that are not specifically tied to a single ply, we absolutely have a solution for that, and that's done within the TruLaser product. So TruLaser picks up where TruPlan leaves off. TruPlan includes all the data you might need for the laser projector in order to do composite-specific projection. Anything you want to do outside the realm of composites, which might be, like you're mentioning, the like a frame around the tool or a footprint where the operator needs to stand, or any type of setup data, that it will be added on later by the TruLaser module. And the TruLaser module can pick up the ball immediately when TruPlan writes out its laser file. So what you would do is you would simply say laser projection, export my data to say Vertec, say OK, and then you would simply read that into a new assembly and add any additional features to the beginning or the end or wherever you need it within the context of TruLaser. And that's exactly why we built TruLaser, to go outside the bounds of just simple projection for composites. Kind of adds that additional feature, adds that additional functionality to do whatever you like. Okay, I think that's it, unless any more came in.
I think there's one more, Anthony, from Eduardo.
How can you project one continuous ply boundary using two lasers? Very good question, Eduardo. So what TruPlan does is it's going to create a single laser projection file, and that is going to include all the definition of each of the plies. One of the things that comes along with that is not just the simple points themselves, but also what we call our normal vector. Okay, So the point is determined by an XYZ location. For each point, we also include what's called an IJK vector. And so that describes, okay, where's this point, but also where's the surface of our tool behind that point. And so, for example, if I had a point here and it had a normal vector pointed out and away from my shroud, that's going to tell our projector that this is a male mold, a convex mold. And so if I've got a laser projector over here, it's best suited to do the work on this side. And if I've got a laser projector over here, it's going to be best suited to do the work on the back side. And that's all based on the normal vectors. If my normal vector, however, was pointed inwards, and that would indicate that this shroud is a female or concave mold, in which case my laser projector over here would not be well suited for these curves because the normal vector is pointed away. The laser projector up here would be better suited for the interior curves back here. So by passing the XYZ plus IJK vectors in the laser projection file, what we're doing is we're allowing the team of lasers you've got on your shop floor to make that decision actively and dynamically based on where that projector is with respect to the tool. So it's an automatic function that is included within the laser projection controller, and it's enabled by the fact that we're passing not only XYZ values but also IJK. So that's the automatic way to do it. There's also a way we can kind of force one laser to do the work versus the other. And that, once again, that takes things just a little bit out of the context of laser projection inside of TruPlan, and it goes into the additional features and functions that we allow with TruLaser, where you could actually take one portion of your ply boundary and associate it to laser 1, and then the other half of your ply boundary and associate it to laser 2. And at the end, when you're ready to actually generate the files, you would not have one file. You would end up having two separate laser projection files, one that feeds into laser 1, one that feeds into laser 2. And in that way, you're taking manual override, and you're now controlling what those lasers have the ability to do. And so that can be a good thing because you can force it to overlap or you can force it to do different things, but it can also kind of slow the system down and increase flicker, because normally the laser projection system is good at distributing those based on where the normal vectors are. So normally we would recommend you leave it all in one file and allow the laser projection system to break down that contour into smaller pieces for each laser depending on where the normal vectors point with respect to the projector. And that's a good question. I think we're going to get into more of those advanced features in a future webinar where we kind of title it, breaking outside the box, breaking outside the TruPlan box. How do you then, go above and beyond what basic TruPlan offers to kind of add additional intelligence to the system? So that's going to be things like, incorporating TruLaser functionality and TruNest functionality. So we're coming back to the top of the hour. If there's no other questions, we'll go ahead and wrap up. Like I said earlier, we're going to have a recording of this webinar available. I thank everyone for attending, and please keep an eye out for an invite for our next webinar that's coming up in July.